Today, we're going to start looking at where our energy comes from and why energy choices matter. Energy affects the environment, the economy, public health, and even global politics. In this first section, we're focusing mostly on conventional energy sources and setting the stage for why sustainability has become such an important topic. Before we get into specific energy sources, it's important to understand what non-renewable resources are and why they're considered a global issue. Much of the world still depends on non-renewable energy, which means decisions made in one country can affect others through pollution, climate change, and resource availability. That resource availability can often lead to conflicts and even war. We'll also talk about the types of non-renewable resources and look at how Florida fits into the overall energy picture. I want you to take a moment and think about the first thing that comes to your mind when you hear the words non-renewable energy. Non-renewable energy comes from resources that do not replenish on a human timescale. These resources form over millions of years from ancient plants and animals or through slow geological processes. Because of this, once we use them, they are essentially gone for future generations. This limited supply is a major concern because global energy demands continue to rise. When you hear the term non-renewable resources, most people immediately think of fossil fuels like coal or oil. That reaction makes sense because these fuels have powered industrial society for over a century. However, non-renewable resources also include nuclear fuel, which works very differently but shares the same limitation. Once the fuel is used, it must be mined or created again. Non-renewable resources fall into two main categories: fossil fuels and nuclear energy. Fossil fuels include coal, oil, and natural gas, which are formed from ancient organisms buried and compressed over time. Shale is a fine-grained sediment rock that's rich in organic material that can trap oil and natural gas within these tiny little pores. It requires a technique to extract that, such as hydraulic fracturing, to pull out those hydrocarbons. Tar sands, also called oil sands, are mixtures of sand, clay, water, and extremely thick bitumen. They have to be heated or diluted to be extracted and processed into usable oil. Methane hydrates are ice-like crystals found in deep ocean sediments or in permafrost. They contain water molecules that trap methane gas under high pressure and low temperature. Nuclear energy, on the other hand, relies on radioactive elements like uranium and plutonium to produce energy through nuclear reactions rather than through combustion. So looking at these fossil fuel sources, we can see this one image A, it looks like a dark liquid. That's petroleum. It's refined into fuels like gasoline and diesel that power transportation. Under B, we see these black rocks. That's coal. It's used as a solid fuel source and has historically been used for electricity. C, we can see a gas stove with the fire coming out of the burners. That's natural gas made mostly of methane, and it's widely used for heating and electricity. In D, we can see a rock structure. This is shale. Hydrocarbons from shale are used for energy, but shale can also be used for construction materials by mixing it into other rock structures. E, we have oil sand. It just kind of looks like a clump of mud. It's used to produce synthetic crude oil, asphalt, and weatherproofing materials. And F, we can see the molecular structure for methane hydrates. These aren't widely used for energy right now, but they're being researched for their potential as energy sources. If we look at this chart of major emissions from fossil fuels, We can see that 79.7% comes from carbon dioxide, and this is directly from burning fossil fuels. Because this is such a major contributor, it's why we often hear a lot of talk about carbon dioxide. Other gases like methane can be more volatile, but they don't make up that as big of a portion of the problem. And that's why we focus more on CO2. Methane makes up 11.1%, and this comes from agriculture, primarily from different livestock. It comes from landfills and natural gas production. 6.1% comes from nitrous oxide. This is from fertilizers and other industrial activities. And then we have fluoridated gases, which contain a fluorine. These come from refrigerants and other industrial materials. Those make up 3.1%. Fossil fuels can create widespread environmental and societal problems. Air pollution from burning coal, oil, and gas can cause respiratory illness and heart disease, especially in communities living near power plants and refineries. Extracting and transporting fossil fuels can damage ecosystems through mining, pipeline leaks, and oil spills. On a global scale, fossil fuel use drives climate change by increasing extreme weather events like hurricanes, floods, and droughts. Because some countries control a large portion of energy reserves, fossil fuels can also create political and economic conflicts. Oil has been called the bloodiest commodity in human history because it sits at the center of global power, military strategies, and economic survival. Throughout the 20th and 21st century, nations and later terrorist groups have fought to control oil fields, pipelines, and choke points that determine who gets energy and who doesn't. In World War II, Germany launched an attack against Baku's oil fields because Hitler believed that the war could not be won without Soviet oil. Japan later attacked Southeast Asia and ultimately the United States at Pearl Harbor after an American-led oil embargo cut off 90% of its supplies. In the 1980s, Iraq invaded Iran partially to seize Kazakhstan, which was home to Iran's largest oil fields. And then both sides attacked tankers in the Persian Gulf. In 1990, Saddam Hussein pushed for the Gulf War, which was a takeover of Kuwait, who had 19% of the world's known oil reserves at the time. Eventually, Iraq was pushed out of Kuwait, and in retaliation, they set the oil fields on fire, which caused massive problems with the environment, especially air quality. In parts of Africa, including Nigeria, Libya, Sudan, and Angola, they all experienced civil wars or insurgencies that were tied to oil wealth, corruption, and foreign intervention. Oil became a source of power for armed groups. Governments relied on oil money instead of public accountability, and this destabilized these areas dramatically. There was a lot of speculation that the Iraq War in 2003 was started over oil, but what we do know is that the collapse of the Iraqi state opened the door for different insurgent groups like ISIS to seize control over oil fields and fund their operations. Groups like ISIS captured oil fields in Iraq and Syria. They sold crude oil on the black markets to fund weapons recruitment and territorial expansions. The oil pipelines became targets for sabotage and extortion. And because of this, terrorist control of oil prolonged these conflicts by giving militants a steady revenue stream. And this caused a lot of suffering for local populations by destroying infrastructure, causing land pollution, and economic collapse. Nuclear energy relies on splitting atoms in a process called fission. Uranium-235 occurs naturally, and it can be used as fuel after enrichment. Plutonium-239 is created inside nuclear reactors and is more efficient, but also more dangerous. So both can produce large amounts of energy without releasing carbon dioxide during their operations. But plutonium poses greater risk because it's more radioactive and easier to use in weapons. So what I mean when I say enrichment is that we're increasing the percent of the uranium-235 isotope. Natural uranium is mostly uranium-238. It makes up about 99.3% of the uranium on Earth. It cannot sustain a nuclear chain reaction. Only a tiny fraction of uranium-235, which is the remaining 7%, is the isotope that can split easily and release energy. Enrichment just means that they increase that percentage of that uranium that's necessary to carry out that reaction, which would be the uranium-235. Even though nuclear power produces low greenhouse gas emissions, it doesn't come without serious concerns. Radioactive waste remains hazardous for thousands of years, and there's still no permanent solution. Currently, the way we deal with this is we take the radioactive cores and put them in what's called spent fuel pools. This is a big bath where the radiation is shielded and the cores remain there for 5 to 10 years. Once they've cooled down, they enter into a dry cask storage. This is a long-term storage site where they're, again, protected from any kind of weather, earthquakes, or any other impact. There have been some countries that adopted what's called interim storage facilities. These are long-term solutions where multiple facilities store their cores in the same spot. The US has proposed this, but it's not actually in operation yet. There's also been the proposal of deep geological repositories, which are long-term plans. The first operation to do this occurred in Finland, in an area called Onkalo. The US has also proposed doing this in the Uga Mountains, but it's not actually active at the moment. Accidents can also occur. One of the worst was in 1986 in the Ukraine. The Chernobyl reactor exploded during a safety test due to flawed designs and operator mistakes. Then in 2011, in Japan, we had the Fukushima plant. This was due to a massive earthquake and tsunami. A little bit closer to home, we had the 3 Mile Island, which was a partial meltdown in Pennsylvania. This occurred in 1979, and it was due to equipment failures and misread signals. These are 3 of the most popular, but there have actually been hundreds of incidents worldwide. Nuclear power plants are also extremely expensive to build and maintain. One structure can cost anywhere from $14 to $30 billion. They can take 7 to 12 years if there's no delays, which often there are. That can expand the construction up to 15 years. They also have environmental concerns. Nuclear power plant construction uses huge amounts of steel and concrete, which produce significant carbon emissions. Building the plant and cooling its systems disturbs aquatic habitats. The fuel cycles tied to construction, such as mining, refining, and enrichment, create radioactive waste and environmental disruption. Transporting materials and equipment adds additional emissions and local impacts. And some materials used during construction will eventually become radioactive and require special disposal. For these reasons, it has become extremely unpopular to build new facilities over the past several decades. Different regions rely on different energy sources. Florida's energy mix is dominated by natural gas, followed by nuclear, then solar. Compared to the rest of the United States, Florida uses less coal and more solar energy. This is partially due to our climate, We have a lot of sun, so solar makes sense. Understanding the energy mix helps explain why some states prioritize certain energy sources over others. There's no one size fits all model. And it's important to understand that, especially when we get into the policy section later on. There are certain reasons why policymakers will choose to support certain energy projects over others. Some of them may be personal beliefs, but a lot of the time it has to do with the resources that are available within that community and the infrastructure that's already in place, as well as the cost.